The Pin Mux tool is a Windows-based software. Wait, what's going on?
If your brain is all in flux trying to do the Pin Mux and your boss is all up on you just causing a ruckus, better get your mind on track. Don't let your focus crack. Head on over to TI cause Sitara's got your back. We'll give you the Pin Mux tool. So man, don't you be a fool. Get online and download now and show your boss how you get down. Get mad props that you can tout, cause yo, that's what it's all about, and you be getting high fives without a doubt.
Are we cool? Are we okay now? Everything good? Sorry about that, folks. I don't know what that was all about. Let's go on. The Pin Mux tool is a Windows-based software tool which provides a graphical user interface, or GUI, for configuring pin multiplexing settings, resolving conflicts, and specifying I/O cell characteristics for Sitara processors, including the AM335X, AM37X, AM35X, and other processors. The result settings can be saved as a design state file or as C header files. To get the latest version of the tool, go to ti.com/pinmux. For the sake of time, I'll go over the Pin Mux tool at a high level, but if you want more in-depth instruction, then the user guide will provide you with more detail. So let's do this. In the Order Now box, you'll see the Pin Mux tool. As you can see on the page, it's a free tool, so really, there is no ordering. Just click on the Get Software button and you'll get your Pin Mux order in 2 minutes or less, or it's free. But it's already free. Ha! After clicking, you'll be taken to the download page. Click on the zip file to either open or save the download, and in a few short moments, your zip file opens up. Double-click the setup application and go through the typical setup procedures that you know and love. When the installation complete screen appears, that means the installation is complete. Thank you, Captain Obvious! Now to start the program, double-click the Pin Mux icon on the desktop. A dialog box will appear indicating which devices are supported by the Pin Mux tool. Select your device and click OK. For this video, I'll choose AM335X Rev 2.x. At program startup, the user is prompted to select the package type and then the voltage that will be applied to the I/O power supply domains that support more than one voltage. You can go ahead and make those selections now or change them later. After selecting the voltages, the main window opens with device data populated for this selected device type. Let's get familiar with this window before doing anything else. I know you're an eager beaver, but simmer down for a moment. The title bar indicates the path where output source files will be stored. The peripheral interfaces data grid shows the current peripheral interface status for the member signals of each peripheral interface. The device package selector controls which package type is used to populate the bottom or top ball location column. The legend describes the color scheme that is used to give a visual indication of the state of each peripheral interface and the state of each signal in the Pin Mux grid. It is legend, wait for it, dairy. The main Pin Mux grid provides a view of all multiplex signals that can be brought out to the pads of the die. Each row represents one pad on the die. Each column, labeled Mode 0 to Mode 7, represents the Pin Mux state at each ball. The status bar indicates the total number of device balls, number of balls remaining, and the number of balls with conflicting Mux settings. The reset button is used to set all Mux selections and pad configurations to the power on reset state. Finally, the close button exits the program. Now, let's get into it. To change the Pin Mux state of the pad, simply double-click the cell. As you see, it turns green indicating it's selected. To deselect, double-click it again. To change a group of cells, click and hold one cell and drag the mouse down the column. Right-click any selected cell and select Change Selected Mux Mode Cells to change the state of a group of cells at once. Go ahead, try it right here, right now in the video. Please don't tell me you didn't fall for that one. I was just having a little fun. One of my favorite things to do is see which signals correspond with specific peripherals. I do that by right-clicking on the peripheral in the Peripheral Interfaces grid. I select View Pins and voila! The interface view corresponding to that peripheral pops up. The bolded items show what cells correspond with that peripheral. Double-click the cell to change the state or change a group of cells with a drag and hold method. Isn't that cool? It's my favorite. Maybe I should get out more. In addition to the cells becoming green, you probably noticed that some are red. Green is good, red is bad. Green means there's no conflict. Red means there's conflict. This is exactly what the tool is for. It helps you understand whether the peripherals or signals you want to use can be used at the same time for your particular design. If there is conflict, use the Pin Mux Grid or the peripheral interface grid to resolve those conflicts. Once you are done with your selections, it's time to save what you have done. As I mentioned earlier, you can save your configuration as a design state file or as C header files. Open up the header files to see what they look like. Just note that for AM37X and AM35X, the generated header files are in the format used by the U-Boot source code. For other supported devices, the source code provides a complete description of all settings, but is not directly usable as a U-Boot source code. The User's Guide Wiki goes into more details about that. And there you have it. You now know how to use the Sitara Pin Mux tool. I hope you found this video useful and it helps you with your design. Be sure to go to ti.com/pinmux for more information and to download the tool. For other Sitara related training, go to ti.com/Sitara training. Thanks for watching and try to do something nice for someone each and every day.